Hey everyone, it's Pam Levitt, also known as That Pam I Am. Today we're going to be digging into JavaScript objects and talking about the differences between dot and bracket notation. All right, everyone, let's go ahead and get started. For our first example, we're going to be working with a basic object with just a few key value pairs. Let's go ahead and get started.
All right, so as you see here, we have a very basic object. We've given it the label of pizza, right? And it just has a few key value pairs. We have a key of toppings, which has a value of an array of strings. And then we have another key of price, which has a value of a number. So the first thing that we're going to dig into is dot notation. So many students run into dilemmas in terms of like, should I use dot? Should I use bracket? Where I would like to point you to is documentation. So I'm going to look up property accessors on the MDN, right? And so all the information that we are covering today is available through documentation, descriptions, syntax, right? As well as examples. So when in doubt, turn to your documentation. But again, let's start off with dot notation. When you are working with objects, whether you are accessing values or setting values, generally speaking, dot notation should be what you reach for first. So if I wanted the value of price returned for my pizza object, I would say pizza dot price, the name of the key, and then that would give me the value back of 16, right? Key thing to remember here is that JavaScript really cares about values. So we'll be working with keys to get values back when we work with objects. Similarly, if we were wanting to set a new property on my pizza object, then we can use dot notation to set a property as well. So let's go ahead and do that. Can say pizza dot, we'll say is tasty, right? And then I'm going to use the assignment operator and set this to the Boolean of true. Now, if I take a look at my pizza object, we'll have that additional property added to it, as you'll see here. So dot notation is very easy to read, very easy to access, as well as set properties on an object. So generally speaking, it is the first thing that you want to reach for when working with objects.
All right, so as you saw there, we really want to reach for dot notation when we're setting and accessing properties on an object, but that isn't your only option, and this is where a lot of people get confused. You can also use bracket notation and pass a variety of different things inside to access or set properties on an object. So let's go ahead and take a look at an example of that.
You'll notice that we have a response object, actually a JSON object that we're working with here. This particular object I've taken from the Star Wars API, and I've modified it just a bit for our purposes here. If you take a look at the keys, most of the keys that are on this object, we will be able to access via dot notation, like the last example. So I could say response.name, right, run that, and I'm going to get that value of Luke Skywalker. Similarly, I could say response.height, and I'll get the value of 172 back in my console. So as I went over before, JavaScript really cares about values. We're working with these keys when we're working with objects to get values back that we want. One thing you might have noticed, though, is that there are a fair number of keys on this object that may look a little unusual. On line 2, we have a key that's a number, which we're able to do in JavaScript. We have one that starts with a dollar symbol. We have some that have spaces in it as well. So let's take a look at how dot notation would work with keys like that. If I do response $ created _at, I can run that, and lo and behold, I'm still getting the value that I want in my console returned to me. That is pretty much it insofar as those unusual keys are working. We are able to access keys with that $ via dot notation because it's following naming conventions for variables in JavaScript. If I were to use dot notation to try to access that key of 1, right, run that, I'm going to get an error back, right? It's an unexpected number. The interpreter is going to have some issues with that. Similarly, if I were trying to access keys with a space in them, like line 7 with hair color, if I say response.hair space color as the key is, I run that, I'm going to get another syntax error for an unexpected identifier. So this is really one of the key reasons why you would use bracket notation instead of dot notation with setting or accessing values on an object. In order to do that, we do square bracket left, square bracket right, we pass a string, and then we pass the key within that string. So if I want that value or from 1, I can pass a 1 in, and lo and behold, I'm getting the value that I need back. Similarly, I can pass in the key of hair color with the space here, right? Run that here in the REPL, and I'm going to get that value back of blonde. So using bracket notation is key in terms of accessing keys that may have some spaces, some weird characters where you're not going to be able to access values via dot notation.
All right, so as you can see, you have dot notation, you have bracket notation at your disposal. Dot notation works in a lot of cases, but there are some areas where you may need to use bracket notation to either pass in a key as a string or a variable, in which case the interpreter will actually coerce whatever you pass through those brackets into a string so you can access the values that you want. So let's go ahead and move on to our last example. Our last example is working with 2 different data sets to get some values that we want from objects. More often than not, as you are programming, you will be working with far more complex examples than the ones that we just reviewed there. Let's dig in.
All right, so we have a couple of data sets that we're working with here. We're upping the complexity just a little bit, but ultimately we are still going to be working with objects and still needing to rely on dot or bracket notation to get to the values that we want. So let's take a look. I have a characters array, right, that has objects within that array, so an array of objects. And then I also have a weapons object, and that weapons object has keys with particular weapon names and values that are nested objects. So the prompt that we're wanting to follow is down here. We need to return the sum, damage, and total range for each character as an object. And here's an example. So this should be our example output based on working with this data, right? A gigantic object that is going to have keys with every character's names and values that are objects that have keys of damage and range with their values, right? So first things first, I think that it's always easiest to try to break the problem down just a little bit as you start to add complexity, which can be hard to do at first, but something like pseudocoding can always help. As I look at my data sets, I can see that the information that I need is across both data sets, right? Not just in the one. I need the names from the first data set, and then the first data set also has the names of the weapons, right? And then if I'm looking at the second data set, I can see that it has the names of the weapons with the values for the damage and range. So when I look at this problem here, the first thing that I would do to break it apart is see that ultimately I want to return an object, right, where the keys are the character names, the values are an object, right? And I'm going to stop there and set up the code from here just because that is just one small little chunk that I can take to get going. As I think about returning an object, the first array iterator method that comes to mind is reduce. So I'm going to set up a reduce, And then when I think about this particular object having keys for the character names, right, I want to reduce over my characters data set so that I can access those keys. Cool. So let's go ahead and do that. I'll say characters dot reduce. I'll set it up here. I know that I want to return an empty object. And then I always like to set up the return for the accumulator, like you see on line 58, just because that can be something that is easy to forget to do. So I've got my accumulator returned. Now I am reducing over my characters array. So we need to set keys for the character names within my accumulator, the object that's returned, and then set a value of an empty object, right? So if I were to do that, I know that reduces callback takes another parameter of the element that I am getting back as I reduce over this array. So we'll name it character, right? It's each character object. And let's try this at first. So we'll say I want to set a new key that is the character's name. If I look at character here, right, and I know that it's representative of this particular object here, within that object there's a key of name, right, that's going to give me back the value that I want, the character's actual name. So I'm going to start off with dot notation and set the key as such and give it a value of an object. So I would say acc dot character name or character dot name, and I'm going to set it equal to an empty object. Let's go ahead and run our code from here. All right, so we're getting an error back, and this is a type error of cannot set property name of undefined. Super common error to run into. The way that I like to think about this error is to look at the property that the error is giving back to you and then investigate what is to the left of that property. So if I look at cannot set property name of undefined, that tells me that whatever is to the left of name is getting returned as undefined by the interpreter. So if I look at line 57, we have name, and then that means that it is not recognizing character, right, as I'm iterating through in my callback. So this is an excellent example of where I might need to reach for bracket notation instead of dot. The interpreter is being thrown off with the dot notation. It is not recognizing character as we iterate through. So I can actually just wrap character.name in those square brackets. And again, what that is going to do is force the JavaScript interpreter to evaluate that value first. And essentially what is happening under the hood is that it is going to evaluate it to a string. It's going to coerce it into a string of whatever the character's name is. And then I can set that string to my object as a property, give it a value of an object. So let's run that and see where we get. Cool. So first step is first, right? I have my object back. I have keys that are the characters' names, and then I have values that are the objects themselves. So now that we've got that first part taken care of, let's go into the second portion and start thinking through that as well. All right, so let's get started on the second portion of our problem. I need to set keys of damage and range to this object that I've created, and then that damage and range is a sum of the weapons for every single character. So if I take a look at my first character, Avatar, right? Avatar has 3 weapons, Mage Bane, Whip, and Axe, that all have different damage and range values, right? So I ultimately want to get the sum back for those particular values and plug them into my object here. So first things first baby step that I'm going to take is actually just to set those keys on my object. Since those keys are static, I know they're not changing, every character object needs those keys, I'm actually just going to modify line 57 and set a key of damage We'll start it at 0 and then a key of range and start that at 0 as well. So when I run this, you'll see, cool. We've got our object set up. Now we have kind of half of our problem set up so far, right? We've got that overall object, we have the keys that we want, we have the start of the values that we want, and we just need to sum the damage and sum the range for all of the weapons that a particular character carries in order to set them on our nested object. So let's take a look at the information we have. As I'm using the callback with reduce, character is giving me access to every object within that array, right? Character is representative of that object. And I can see here that there is a property called weapons with a value of an array of strings. And every one of those strings, turns out, is a key on this data set down here that is going to give me the value that I need, this object that holds nested keys of damage and range, which is what I'm trying to get to. So to start, I'm just going to try to get back the keys from every character. In order to do that, I can just iterate right over that particular weapons array. So from here, we could say character.weapons, which gives us that array of strings, and we can for each over it. Every string is a weapon, so I'm going to name it as such. Right? So from there, I can start thinking about how I could get to those values of damage and range. Well, we're working with an object, so we should be able to use either dot or bracket notation to get to those values now that we have the keys that we need. So thinking about my accumulator, right, I'm going to need access to that. Right? I'm going to need access to the particular character that I'm working with, right? And then from there, I could set my damage, and then I could also set my range, right? Since I know that I am summing values as I iterate with the for each, I'm going to use plus equals, right, to make sure I'm getting to the values that I want. So now the trick here is on the right-hand side of how do we get those values, right? How do we get all the way down to 10 and 5 to actually add those values? If I think about my weapons object, I wonder if I could just use dot notation to start, right? I have weapons, which is the overall object, and then I have these keys that are changing every time, right? But theoretically, I have access to those changing keys via the weapon parameter in this callback. So I could say, hey, access the weapons object, use the key of whatever weapon we're dealing with right now, and then from there, use dot notation again to get either the damage or the range to add those values. So let's give that a go and see what happens. Cool. So running it from there, aha, there's that same error again, right? Cannot read property damage of undefined. And remember, when you hear this type error, always try to think of what's to the left of the property that it's naming. So if we look at damage, right, what is to the left of damage? To the left of damage is weapon, right? So again, this is an instance of the interpreter running into an issue with dot notation. And in this instance, it's running into that issue with the keys actually changing. So in order to fix that, this is another example of where we would reach for bracket notation to force JavaScript to evaluate whatever is in the brackets before we're actually setting or accessing values. So let's change it here. I can say weapons, oop, not right there. And using bracket notation instead of dot notation here, let's run it. And there you have it, right? If I replace the dot notation with bracket notation, and wrap that around my weapon, which remember, it's changing every time that this callback iterates, then this forces the interpreter into evaluating whatever weapon is on that iteration, coercing it into a string, and then accessing that as the key that we need from our weapons data set, and then eventually using dot notation to get down to that damage. So if I take a look here at my console, right, we're getting back what we need via the prompt. We are adding the values with damage and range. We're giving back that overall object with the keys that we wanted. Hooray.
All right, so as you can see, when you work with objects in JavaScript, you will be working with property accessors. You can reach for either dot or bracket notation, but a lot of it is going to depend on what you need to solve the problem. Let me know your questions down in the comments below. Make sure to hit subscribe so you can catch all of my future lessons, and I'll see you later. Bye.